Hi, everybody. We haven't had the chance to meet yet, but my name is Robin Dahl, and I'm the instructor for this course. I wanted to take a minute to introduce myself and to talk a little bit about the summarizing questions for Chapter 1, just to make sure that we're all on the same page with kind of the takeaways from this first chapter, and for you to get, a mental picture of me and to know who you're emailing when you email me with questions. So first off, I am a faculty member in the geology department and the SMATE program at Western. My specialty in geology is paleontology, so I study the history of life on Earth. If you ever want to talk about fossils or talk about how we know, what Earth was like millions of years ago, I'm super stoked to talk about that. I'm excited about this class. This is one of my favorite classes that I teach at Western, and it's definitely weird to be teaching this class online. And to have restructured it to be basically completely individual work. Normally this class is really centered around small group work and discussion and sort of collaborative learning. So I'm kind of figuring it out as we go. I'm sure you're doing the same in all of your classes. I really want to encourage you just to email me as much as you need to. I'm trying to be really quick about my responses. And I'm also available to talk about things if you ever want to schedule a video meeting with me or log on to any of my video office hours. So hopefully you'll be able to get as much out of this online version of the class as we would normally in an in-class quarter. Okay, so let's talk a little bit about the summarizing questions for Chapter 1. Chapter 1 is the shortest chapter that we have. It usually is done in a couple of days in the in-person version of the class. And I actually opted to take out the primary activity that we do in this class, which is a scaled up version of the investigation of the dice that you did. So you thought about making observations on a single die and kind of using what you can see to figure out what number is on the bottom. And we would normally do the same thing with a more complicated, larger cube that has words and numbers and colors on the sides. And so the purpose of that activity is to kind of get you thinking about how you can use observations to make inferences about things that you can't see. And that is a really important concept in science in general, and especially in earth science. Earth science is a little bit different from some of the other sciences like chemistry and biology and physics and things like that, because the scale that we need to think about things when we think about the Earth and about geologic time is really different than the scale that humans live on. And so that's something that we actually discuss in Chapter 2 that you've already started to think about a little bit. Some of you have completed those activities, some are just starting them. But it's something that we're going to come back to again and again. And it's something that gets addressed in the summarizing questions. So I think you all did a great job on the summarizing questions, and I just want to talk through a couple of these and let you know how I would think about them and sort of where I hope we would all end up. So big takeaway from this chapter, of course, is the definitions of observations versus inferences. It's probably something that you kind of intuitively knew, but maybe didn't think about in detail before. So clearly an observation is something that you can directly observe through your five senses. So things that you can see or hear or touch or taste. In geology, sometimes we taste things to see what they are, or smell. And the inferences are hypotheses or ideas that we develop using things that we can directly observe. So we might infer things about, for example, the core of the Earth without ever going there. It's literally impossible for a human to travel to the center of the Earth because of the pressure and temperature conditions as you go deeper outside the planet, but we know a lot about the core. We know what it's made of, we know how thick it is, we know if it's solid or liquid. It's actually both, depending on what layer you're talking about. And we know all of that because of observations that we can make about some things that allow us to infer things about other parts of the planet that we can't actually access. So the main question that I wanted to discuss was actually the last question, which was if you think that the difference between an observation and an inference is more critical in earth sciences than it is in other sciences. And there were a range of different answers that you all gave for that. And I marked you all correct regardless of what you said, because it's sort of a thinking and a discussion question rather than one that has a clear, correct answer. But the way that I think about that is that, like I said, earth science is different from other sciences. So sometimes it's what's called an observational or a historical science. And what that means is that we look at clues, facts, we make observations about the objects that we can access on the surface of the earth to put together information, inferences about the interior of the planet and about Earth's history. We can't run an experiment. We can't build a planet experimentally and figure out what happens in planetary accretion. And we also can't run an experiment on geologic timescales, which are hundreds of thousands to millions to hundreds of millions to even billions of years. We can't do that. We can create computer models based on the observations that we make, but what those models tell us are inferences. So that's what I mean when I say that earth sciences are the earth sciences are a little bit different than other sciences. The way that we study the planet is more focused on putting together your observations and using those to make inferences rather than sort of creating an experiment and running a test. So I hope that that helps to clear up any last remaining questions that you might have about chapter 1. And after this chapter, we move into more actual geologic content. So we're going to start with learning about the different types of rocks and how we know how rocks form. So I will periodically be posting videos like this to share information with you when I think that something can be explained a little bit more, or we can sort of go a little bit farther, or when I think my perspective might be helpful in clarifying your thinking on things. So that's it for now, and great work on the class so far, and I hope you're enjoying it. All right, I will talk to you all later.